tell you, it's been a crazy week already.
Miss Woodblack,
Mm-hmm.
chapter 26, do you know when you're going to put that homework in?
I was going to try and get it in today, but I haven't gotten it there.
Okay, I was just wondering. It's gonna help a lot of our grades, I think.
Actually, your lab grade helped a lot of your grades. I don't think one homework problem at this and one homework at this point is going to help your grade that much.
Yeah, probably.
You know, come on, guys. Come on, guys. Okay. So where we are is if I have for in series, right? So I've got resistors in series. My equivalent resistance is going to be Req is equal to R1 plus R2. If I have it when they're in parallel, this is going to be the equivalent as Req is equal to 1 over R1 plus 1 over R2. Okay? So we've had those systems, so I'm going to do a quick problem here just to get us warmed up. We're given a battery has an EMF of 15 volts and terminal voltage, so I'm taking my handy dandy volt multimeter and I'm reading my terminal voltage is 11.6 volts. It's delivering 20 watts of power to an external load. So we get 20 watts of power to an external load. So essentially what we've got is a system that looks like this. Has some sort of resistor, we just don't know what it is, and it looks like that. We want to find the external load, and we want to find the internal resistance. So I'm going to use power is V squared over R. So power R is equal to V squared. R is going to equal V squared divided by power. This V is what the terminal voltage is. That's going to be my 11.6 squared divided by my 20 watts. And that will give me an R of 6.73 ohms. And I gotta have this because my equation to find my internal resistance looks like that, so I need current. Because we're given this and we're given that, we want to know this, but I got to find current. So I'm going to use this to find current. So current is equal to V over R. We know this is 11.6. My R is 6.73. So my current ends up being 172 amps. So this becomes V minus E divided by negative I gives me R. So this becomes 11.6 minus 15 divided by a negative 1.72 amps. And my little r ends up being 1.98 ohms. that one. And gotta start with one of them sooner or later. Okay. All right, so we have two rules. And we'll start with this one. Okay, there we go. There's what I'm looking for. There's what I'm looking for. There's what I'm looking for. All right. I got a lot of ways to do it. Oh, and I have to get, okay, so we're gonna start with this system. Okay, oops, I left out a resistor. I want a resistor here too. This is a 10 ohm resistor, this is a 10 ohm resistor, this is a 5 ohm resistor, this is a 20 ohm resistor, and this is a 5 ohm resistor. The first thing that we want to do, okay? The first thing that we want to do, and we're told, by the way, that this is a 25 volt battery, is we want to find Req. If I'm in series, they just add together. So this group is now 25 ohms. So now I have 1, 2, 3, 4 in parallel. Actually, I don't want to do that one because this will end up in series. So I have 1, 2, 3 in parallel, so I'm going to get 1 over Req is equal 1 over 10 plus 1 over 5 plus 1 over 25. And if you're into fractions, lowest common denominator is 50. So this is 5 plus 10 plus 2 is going to give me 17 fiftieths. So Req is 50 seventeenths, and that works out to be 2.94 ohms. Then this becomes in series again, so I'm going to get Req is going to equal my 10 plus my 2.94 is going to give me 12.94 ohms. And that's for the whole system. So for the whole system, I can figure out this current now, because that current is just V is equal to, or I is equal to V over R. This gives me 25 divided by my equivalent resistance for the whole system, and this gives me 1.93 amps.
Can you scooch it down?
That's the best I can do, get everything on the page. Okay. Now, if I'm looking at this system, one of the things that we said is when it hits a junction, I'm going to get a current going, splitting off. And it'll hit another junction, and it'll split off again. And I'm also gonna give myself a couple of points. I'm gonna have A and I'm gonna have B. And now what I want, I'm gonna call this I3. And I wanna find the current I3 and I wanna find the voltage across A and B for that system. So the first thing I'm going to do to help myself out is I'm going to redraw my circuit a little bit. There's a 10 ohm resistor here. And this is a 2.94 ohm equivalent resistor, because that's what we figured out right there. So if I have my current going through here, we've got the voltage. Voltage is going to equal V1 plus V2. And V2 is going to equal the current going through the system times the resistor. And my current is 1.93. The resistor that I have is a 2.94. And that gives me a 5.98 volts. And what happens here is when I have something in parallel, if I do this as 1, 3, 5, and this is 2, 4, 6, voltage across 1, 2 is equal to voltage across 3, 4, which is equal to the voltage across 5, 6. So therefore, my voltage at AB is going to be the same as that 5.98 volts. And then when I look at I3, what I'm looking at is this current that's coming in like this. I is going to equal the voltage divided by the resistance. And remember, this is a 20 and this is a 5. So this voltage is the one that I put in, 5.98 volts. My resistance is 25. The current ends up being 0.227 amps, or 227 milliamps. I'm going to do another equivalent resistor before we jump in. Okay, so this time I'm given a system that looks like this. This is 100 volts. This is 100 ohms. This is 200 ohms. This is 100 ohms. This is 150 ohms. This is 300 ohms. and this is 100 ohms. And I want to find the REQ. So the first thing that I'm going to do, if they're in series, they're additive. If they're in parallel, they are inverse. So I'm going to do this one, and I'm going to do this one. So 1 over REQ is equal to 1 over 200 plus 1 over 100, which is going to give me, my common denominator is 2, it's going to give me 3 over 200. So REQ is going to equal 66.7. This one, 1 over REQ is equal to 1 over 300 plus 1 over 100 gives me 4 over 300, which works out to be 75. So now I have 100, 66.7, 150, and 75. So my system is going to be 100 plus 66.7 plus 150 plus 75 gives me 391.7 ohms. If I want current for the system, that's going to be 100 divided by 391.7, which is going to give me 0.255 amps. All right. We're ready. Here comes Kirchhoff's rules. We're going to start with a simple one, and then we get gory. But this will get you one to get started. So I'm going to start off with a circuit that looks like this. This is going to have 2 batteries in it. Three resistors. This one is going to be 10 ohms. This is going to be 12 ohms. This is 20 ohms. This is a 7-volt battery. And this is a 1-volt battery. And what we want to know is what is the current through each leg of the system. Okay, so how you do these problems is as follows. First thing is give yourself some reference points. So in this case, I'm going to give myself an A, a B, and a C. The next thing you want to do is you want to guess or pick the direction of the currents. So if I'm drawing it like this, I'm going to pick this one as my I1. This one is going to have my current come up to this point, and if I've already got current coming in here, and I got current coming in here, I'm gonna pick an I going that way. And then that I and this I and this I are the same, so this is gonna be my I2 going into that node, and this one's gonna be my I3. Now, if I pick wrong, one of my currents is gonna come up negative. Okay, so solving the problem, if I get a negative current, it says I drew it wrong. We have what's known as the junction rule. And we have what's known as the loop rule. I have 1, 2, 3 unknowns. So I've got to have 3 equations. And they've got to be 3 independent equations. 3 unknowns, 3 independent equations. 2 unknowns, 2 independent equations. 4 unknowns, 4 independent equations. 5 unknowns, you're getting the picture. Now we see that that's simple. These get ugly very quickly. And I will show you another way of solving the ones that get really, really hairy. But my junction rule says all the sums of the currents going into a junction have to equal 0. My loop rule says as I go around the loop, the potentials have to equal 0. Now, one of the currents that I didn't put back in here is if I go to C, I have to have current 1 come back out. So if I go to my junction here, my first independent equation is that the current going in, I1 plus I2, has got to equal the current coming out, which is I3. And if I look at this one, I3, I'm leaving I1 and I2 is going up there, so whether I pick junction B or junction C, I get the same equation, so I don't get independent equations. All right, there are 3 potential loops in the system. Okay, I have 3 potential loops. I have the loop that does A to B to C to A. So I can call that loop A, B, C, A. I have the loop that goes A over here, down through here, back here, A. So I have the outside loop, we'll call that the outside loop. And then I have the loop that does just this side here, so that one is B, C, B. So I have an outside loop, I have this loop, and I have this loop. So I actually have the potential to have one more equation than I need, which is good, because then I can use that as a check. So I'm going to do loop, let's do loop A, B, C, A. So the easiest way to do this, I'm going to start at C. I have a voltage, that's V1. If I put in the battery, I have the battery and it's positive. Unless I'm going backwards through the battery, okay? If I draw my current, and you'll possibly run into this where you're going to get the way your loops are, it's going to look like that, and all of a sudden I got my battery as in backwards, and if I'm going the wrong direction across the battery, I got to put a negative. Then each time it goes across the resistor, I'm going to get a potential drop. So now, if I do this, I'm going to go across this resistor, I'm going to get a drop, and it's going to be the current that's going through that first resistor times the resistor. Now, if I am coming through and I'm going from B to C, this is where I'm going backwards across the battery. So that's minus V2. I come back through here, there's no other resistor. That's got to equal 0. Well, this is nice because the only thing that I don't know in this equation is I1. So I'm going to go ahead and solve for that. I got 1 minus I1. I have my resistor is a 10. And I have this is 7. It's equal to 0. So I get minus 6 minus I1 is 10 is equal to 0. I get 10I1, because I'm going to put it on the other side, is equal to minus 6. I get I1 is equal to negative 0.6 amps, which tells me that I picked my direction wrong. I picked my direction wrong. Which kind of makes sense, because I have a 7-volt battery here, and I only have a 1-volt battery there. This is actually going to go and split off. So now I can do, let's see, we can go and do the outside loop. So my outside loop, I have V1 minus I1 R1 minus I2. Oh no, that's not I2, it's I3 R. This one's going to be 12. And then I get a minus I3 R20 has got to equal 0. I already know these numbers, so I know that in this case I'm going to get V1 minus, this is 0.6, it's a minus 0.6, based on how my picture is drawn. With a 10, I have a 12 I3, I have a 20 I3, that equals 0. This is V1, so it's 1. And this becomes a plus 6, right? 0.6 times 10 is 6. Minus 12 I3 minus 20 I3. So I have 7 minus 32 I3 equals 0. I get 7 divided by 32 is equal to I3. And if I plug that into the calculator, this gives me 0.219 amps. Now I can do I1 plus I2 is equal to I3. I2 is just I3 minus I1, which is going to be, I'm going to get my 0.219 minus a minus 0.6. I end up with 0.819 amps. And then you have a third equation that you can use as a check. Okay.
What? Okay, so we got a negative on I1.
Mm-hmm.
Do we not have to, like, try to get a positive?
It just says my picture's wrong.
Oh, okay.
So if the picture were right, would it have just been 0.6?
If the picture were right, it would have been 0.6.
Oh.
Okay, that's where I was like getting kind of confused.
Yeah, all it's doing is saying, in reality, what this is telling me is this current's gonna go this way across the resistor instead of this way across the resistor.
So like the number is right, but it's just the direction.
The direction's wrong in my picture.
Okay.
The direction's wrong in my picture.
Okay, but then when we solved for the other i's, we still use the negative.
Right, because I'm going with my picture.
Okay.
So when you did the outside,
Mm-hmm.
you did I1, I1, R1,
Mm-hmm.
and then you did I3,
Right, because the current that's going through this one is I3,
so the current is going through that one here.
is I3.
How's it I3?
Because it's after this junction, and this current around this one is I3.
So when you have a battery like that, you go straight out from your battery, and that'll give you your arrows essentially.
Mm-hmm. Well, we're about to do another one. Let's look at another one. Okay. So this time I have a circuit. I've got a battery. I have a resistor. That's one side of my circuit. Okay, this is given to us as 6 ohms. This is given to us as 20 volts. This is 5 ohms. This is 4 ohms. And we don't know this battery. We don't know this battery, and I have one here, shoot. I have another resistor right here. And this is a 4 ohm resistor. This time the problem gives us a current. It's telling us that this current is 4 amps. We're gonna come in here and I'm gonna go that direction with my current. And I'm gonna call that one I2. This one, we're coming in this way. And this is I'm gonna make this I3 because this is I2 and this is gonna equal 4 amps. We want to solve for I3, EMF1, and EMF2. When it comes out of here, this is going to want to go here, and this is going to be I2. This will come around here, and this will be I1. So according to my junction rule, I have I1 plus I2 is equal to I3. That's going to be easy because we're told that that's 4 amps. Plus 4 amps is going to give me 8 amps. So I know I3 is 8 amps already. I don't have to do anything crazy. So I'm going to give myself some reference points. I'm going to call this A, this B, that's C, and this one's D. So I'm going to do loop A, B, D, A. A, B, D, A. All right, I'm going to follow the current from A this time just to make my life easier. So this one is going to be, I have a current drop, so it's I3 times my resistor, which is 5. I'm going through my battery correctly, so that's a plus E2. I'm coming out here, so that's minus I1, 4 ohms. I'm going through this battery correctly, so that's plus E1. And then I'm going through I1, 4, has got to equal 0. So the first thing I'm going to do is clean this up a little bit. I'm going to get my E1 plus my E2 minus 8I1 minus 5I3 equals 0. Now I'm going to do this loop. So I'm going to do loop, and I'm going to go correctly. So I'm going to do C, A, B, C. So I'm going to get a minus I2 times my 6 ohms plus 20 volts minus I3, 5 plus E1 or E2 is equal to 0. Since I know I2 and I know I3, I can solve for E2. So I'm going to get E2 is equal to 5I3 plus 6I2 plus 20. I3 was 8, so it's 5 times 8. I2 was 4, so it's 6 times 4. And I have my plus 20. So I get my 5 times 8 plus my 6 times 4 plus my 20 gives me 84 volts. Oops. It's a minus 20. Because that's a minus. This gives me 64. No. That's 40 plus 20, yeah, gives me 64. And I'm about to lose you guys over Enid. So we will pick up there.
So how come it's a negative voltage?
Because I took it to the other side. Yeah, I took it to the other side. Yep. So you got you should bring something else.
There's a way
So let's go look at it. We want to make sure that that's done.
I just,
And we'll see what
the
was.
safety net there just in case.
Well, business ethics is 3 hours. We can add it right now. And I think that'll still keep you, as it starts on Monday. Does it start on Monday? It starts on the 14th.
Okay.
Yeah, so let's go get you an asset.
I do a lot, but I can be late.
Yeah. What's that?
I was gonna tell you, I'll go to visit OC next week. And we can talk to you about the issues.
Yeah, let's look at them. I've got them all printed out.
Well, the bell guy, is he gonna be here before 9, like when we're working on it?
I honestly don't know. I'm not 100% sure exactly when he's gonna shift, exactly what time he's gonna